Hello everyone, my name is Ben Fischer, and today I'm going to be talking to you about observables. Now some people may already be familiar with the concept, but some people have maybe never heard of this term in their life, so we'll start with a quick definition from the ES7 proposal to make observables part of the standard library. So the definition is they model push-based data sources such as DOM events, timer intervals, and sockets. Now that's a pretty short definition because most of it is actually just examples, things that are modeled with observables. So the whole definition is really just they model push-based data sources. So what is the difference between pull and push-based data sources? Well, a lot of the standard data structures that you learned about if you took some type of data structures computer science class, like arrays, stacks, queues, trees, linked lists, hash sets, generators, are pull. And they're pull in the sense that when client code wants to get values from these structures, it pulls the values out of them. And the opposite of that is push, meaning that the data structure itself is an entry point to the application, and you sort of register some type of callback code that will receive the value when the data structure determines that a value is ready. So observables are an example of this type of source. Channels in Go are something that can push values to client code. A Redis client could get values coming in by subscribing, or a Kafka client. Those are examples of things that would push values to client code. So what we're looking at right now is a stream of values, 0, 1, 2, 3, 4, on and on and on. So if we wanted to model this in JavaScript without using observables, the way we might implement it is something like this, where we define a function called interval, and it takes a period and callback, and then initializes a counter and uses JavaScript's setInterval function to set an interval for the period, and then at each period it invokes the callback with the value and increments the counter. So the last line is just an example of using it, where we say every 1,000 milliseconds we will console.log each of our values. And the output of running this, the console log function we will call a observer. So the output of running this is 0, 1, 2, 3, 4, and on and on and on. So that works. It achieves what we want to achieve, which is getting those values. But to actually model that stream requires more than just modeling how we can get the values. So if I said, let's reason about that code we just wrote, people might sort of struggle to answer the following questions, like, can the stream ever signal completion? Can an observer be unsubscribed? What are the mechanics of when the stream will start and stop emitting values? Can the stream emit errors? Are values shared between different subscribers? How can this stream interact with other streams that we might create? So that's where observables start to provide value, because they are a formalized way of modeling these streams that will help us answer these questions. So if we look at that same stream, once again, 0, 1, 2, 3, 4, and this time we want to model it with observables, it would look something like this, where as we saw from the definition earlier, observables are not part of the standard library in JavaScript yet. It's part of the proposal. So you have to import some library that implements them, like RxJS. And then there's an observable class on that namespace, and it has an API that will let you create observable instances. In this case, some method called interval. We don't exactly know what it's doing yet, but we know it's creating an instance of an observable. And we see this other API, subscribe, which lets you register an observer to your observable. So this looks a little bit different than what we had before, because last time we had the period, the 1,000 milliseconds, and the observer sort of combined into one call. So now it's two different calls, but pretty short, pretty simple, and it does the exact same thing as our other code did. So we get 0, 1, 2, 3, 4, and on and on. So what we're going to do throughout this presentation is build up a list of properties, things that we know about observables. And right now we don't know too much. We know that they emit values to observers, and we've seen that they can do so asynchronously. So every 1,000 milliseconds, new values come in. So that's really all we know. But by the end of it, hopefully we know a lot more than that. So one of the first questions we asked is, can the stream ever signal completion? So I wrote a new marble diagram at the top, so it starts with 0, 1, and then dot, dot, dot. We don't know if there's going to be more values. Maybe there is, maybe there isn't. But then there's a bar saying And now we know there will be no more values. All values are done. So that's what we sort of want. We want the stream to be able to tell us there are no more values. So to implement that with RxJS, it might look something like this, where we start with the same observable that we saw before, RxObservable interval for every 1,000 seconds, and then we add something in called a filter operator. So we see we're calling this method called take and giving it the argument of 2, and then at the bottom, we've split out our subscribe call into multiple different callbacks. So the console.log is the onNext callback, and then there's null, that would be for errors if we want to register an error handler, and the last one is the onComplete handler. And the three of those collectively are all part of the same observer object, but it can register different things to do if there's values versus errors versus a done or onComplete signal. So that's all the code, and it would output 0, 1, and then done. Okay, so it does sort of what we want. But what is really happening here? So we're starting with an instance of an observable, which was created by that interval function, and it returned the same thing we had originally, 0, 1, 2, 3, 4, and on and on. And then when we use operators, like what we saw with take, those are pure functions. So they're not going to modify the observable returned originally, 0, 1, 2, 3, 4, and on. They actually interface with that original observable, but create a new one. So they don't modify the arguments they take in, they just create something new. So the take operator will get each value from its ancestor and emit it until n values are reached, and then signals completion. So the question is, what is this interface between, like, how is it that whatever observable take is creating somehow gets the values from the first one and then stops? And the exact mechanics of how these two are interfacing with each other is still a little bit hazy, but the concept is we can chain these operators on each other on the observable to compose new observables. So we'll look at that more in the next example, but for now we know a couple new things, new properties of observables. So now we know that they can signal done to observers if you register an onComplete callback, and that they have these chainable operators that will compose new observables. And we've seen so far that we can use those chainable operators to filter out values from the stream. So the next question we had in our list of questions is, can subscribing be delayed, and can we unsubscribe our observer? So if we wanted to implement something like that, you would see that we'd start out the way that we started out before, which is using that interval function to create an observable. And then this time we're using this operator called do. So last time we used take, but do works a little bit differently. It's sort of the identity operator. It won't change any of the values at all that come through the original, but you can sort of do side effects within that function. So in this case, we're going to console.log still going. So even though we're not touching any of the values, you know, maybe we'll still see still going. And then we wait 3 seconds to initially subscribe, and then we unsubscribe after 7.5 seconds. So this code sort of has two possibilities of what it might output. On the one hand, on the left, when we define the observable, we might immediately start seeing still going, still going, still going, and then after 3 seconds, when we subscribe, the value's at 3, so we see 3, and then we see still going 4, 5, 6, you know, on and on. And then after we unsubscribe, the observable's still around, so it does keep going, continues outputting still going because of that identity operator that we're using to log still going. Now the other possibility is that we see still going and the initial value that we get is 0, and then still going 1, 2, 3, and then after 3, nothing more. So those are the two extremes of what we might see, or maybe something in between here. And the correct answer of what we're going to see is actually the one on the right, where we don't see still going until we get a value, and we don't see still going anymore after we stop getting values. So what does that tell us? That tells us that nothing happens without a subscriber. So if we look at the marble diagrams to see what we're creating, we see initially interval creates this 0, 1, 2, 3, 4, and then when we chain the do operator onto it, it doesn't modify the original stream, so still 0, 1, 2, 3, 4. But what happens is when you subscribe to that second observable created by the do operator, internally it subscribes to its ancestor, observable 1, created by the interval operator, which then begins the flow of values. And unsubscribing follows the same subscription chain and unsubscribes from observable 2, which unsubscribes from observable 1, which then clears the interval it's set up to emit values. And that's why you don't see still going until there's a subscriber registered, and the values that we start with are 0 because it wasn't just ticking away without anything listening. It waited for someone to start listening, and then when someone stopped listening after 7.5 seconds, it didn't continue to emit values, so there wasn't any more still going logged out. So we know a little bit more about observables now. We knew that they emit values asynchronously, but we now know that they do so lazily, meaning they will wait until there's a subscriber before they start emitting values. We know that the observers can unsubscribe, and we know that when you do chain these operators to compose new observables, they will share a subscription chain, and that's sort of the mechanics of how they lazily emit values to the observers. And we've seen that there's an additional operator. We saw take, and now we've seen do, and that one's kind of used for debugging and sort of inspecting where we're at with our stream of values. Okay, so let's take a look at another example. So this time we're going to introduce a second subscriber. So we see once again the interval operator, which will create the 0, 1, 2, 3, 4, and then we immediately subscribe the console.log, and then after 2 seconds we subscribe again, and this time we're subscribing with a function that will take the value and console log the value plus an exclamation point. So first observer, second observer. The sort of two options of what we might see in the output are 0, 1, 2, and then the second observer joins in and it starts at 0 with the exclamation point, 3, 1 exclamation point, 4, on and on and on. And the second possibility is 0, 1, 2, and then the second one joins in and it gets the same value that the first one had, so it gets 2 exclamation point, then 3, 3 exclamation point, 4, on and on. And what we'll see is with the code we wrote that we get the first one. So that tells us that observables can be cold, sort of like YouTube. If two different people go to a YouTube video and the first one hits play and someone else comes in 2 seconds later and hits play, they're not watching the same frames at the same time. They're each watching their own copy of the YouTube video, and then they each get their own series of values, so they're sort of independent of each other. And that property of streams is called being cold. So you would think, well, if an observable can model a cold stream, is there such a thing as a hot stream? And I think you can guess the answer is going to be yes. So here, once again, we take the interval function to define the stream of 0, 1, 2, 3, 4, and then we call this publish API on it. And calling publish is kind of like subscribing in the sense that once you call publish on a stream, it knows to start emitting values. So and that's combined with the connect API. And actually, I might have been wrong about what I just said. I'll have to look into that a little bit more, but calling connect is probably what starts the emission of value, and calling publish is probably what says we will mark this stream as being hot. So we'll assume that's the case. But regardless, either way, we call connect, and then after 3 seconds, we've set a timeout, we will subscribe with the console log function as the observer. And then after 5 seconds, we will subscribe again with the same thing we saw before with a function that will console log the value plus exclamation point. First observer, second observer. So this time, instead of starting at 0, we're starting at 2 because the first subscriber didn't subscribe until after 2 seconds. And then we get 3, 4, and then the second subscriber jumps in and it gets 4 exclamation point. So you can see that they're getting the same values at the same time, so 5, 5 exclamation point, 6, 6 exclamation point. So that property of a stream is called being hot, sort of like television, where if I turn on the Super Bowl and someone else was watching the Super Bowl, we're going to see the same frames at the same time, sort of, because we're looking at a live stream. So streams can be both cold and they can be hot, and observables can model both of those properties. Okay, so far everything that we've looked at has been using that interval function on the observable class to create a stream that will emit integers over time. But ArcGIS has other APIs that you can use to create observables, and you can do so in a slightly different way. So we see the marble diagrams at the top, 1, 2, 3, all in parentheses, meaning that all those values, 1, 2, and 3, are available immediately. We're not waiting. The values are all there. And the second stream being Jill, Sarah, and Amy, once again, we don't have to wait. I mean, they are 3 distinct values. However, they're all available. So if we look at the code, we start by creating this number stream. The $sign at the end of the variable, I don't think I've mentioned this, is just a convention that indicates that the contents of the variable are a stream. So we have a stream of numbers, and we're using this of operator to create that observable instance. And then the second line is the stream of names. So we got Jill, Sarah, and Amy, and stored in the name stream. And then we're going to look at 3 different techniques for combining those 2 streams. So the first example, we see we're creating a stream called latest, and it's using this operator called combine latest to combine the name stream with the number stream. And the second one is using the name stream and the operator zip to combine it with the number stream. And then the last one is using the name stream and the operator merge to combine it with the number stream. And then we're mapping the values from that stream, and we're calling toString on them, and then to uppercase. And then at the end, we subscribe to latest, zip, and merge streams, and we just sort of console log them out with a little prefix saying how they're being combined. And what we want to know is there's these 3 different techniques: combine latest, zip, and merge, and how will they combine values from streams differently. So latest, we see we would get Amy, 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 Amy 1, Amy 2, Amy 3. In other words, Amy every time, and then 1, 2, 3. So what combine latest is doing is it waits for silence on its initial stream. So if we go back and look at the names, we're starting with the stream of names. So we have 3 values available immediately: Jill, Sarah, and Amy. So it sees, I've got values, I've got Jill, but I can keep going. I've got more values, I've got Sarah, but I can keep going. I've got more values, I've got Amy. So it takes the latest value, Amy, and then there's silence in the stream, no more values are coming, and it looks at the other stream, the number stream, and combines the latest value from the first stream with each value that comes out of the second stream. So that's why we get 3 times. We get Amy 1, Amy 2, Amy 3, because each value, the latest value from the first stream, is combined with every single value from the other stream. Now zip works a little bit differently. We get Jill 1, Sarah 2, Amy 3. And if we look at our marble diagrams once again, we see that corresponds to the order that they were in. So Jill was 1, Sarah was 2, and Amy was 3. So that one works more like a zipper, where it takes a value from the first stream and it waits until it gets a value from the second stream, and then it combines them both. And then it waits for a value from the first stream and waits for a value from the second stream, combines those 2, and waits for a third, waits for a third. So we get zipped up like a zipper. And in the last one, we see that we get Jill in all caps, Sarah in all caps, Amy in all caps, and then 1, 2, and 3. And so merge, what it does is it waits for a value from either stream. So it got a value from the name stream, emitted it immediately. It had another value for the name stream, emitted it immediately. It had a third value, emitted it immediately. And then each time it gets a value from either stream, it just emits it. So whenever either stream has a value, you get the new value. Okay, so we've learned a couple new things about observables. Not only can we model asynchronous streams, we can also model synchronous streams. And we've seen a couple additional examples of operators. So we've seen 3 different ways to merge, or another phrase for this is to combine streams, and we've seen that we can combine them vertically in the sense of multiple different streams being combined together. And we've also seen with the map function that we can take values from a stream and transform them into other values in a new stream. Okay, so now let's take a look at a little bit more complex example of maybe like a type ahead type functionality. So all the examples that we've been looking at so far have been run just in Node, not in the browser or anything. And so what we'll do is look at, without actually involving the DOM API, we'll just simulate a stream of characters in a way that the browser might. So we use the interval function that we're accustomed to, and we map the values from that stream that are coming out every 500 milliseconds to a character code. So we use the string from character code and map it to some letter. So every emission will start with 0, that'll be A, and then 1 will be B, and 2 will be C, and on and on and on. So that's sort of the stream of characters, almost like a user typing the alphabet on a keyboard. A, B, C, D, E, F, G, on and on, every 500 milliseconds. Okay, but usually in a type head, you want to know the phrase that's being typed, not just like the most recent character that they typed. So if we have a stream of letters, we want to horizontally combine those characters, each character being a value in the stream, into a phrase. So we use the scan operator, which users of any collection API and maybe JavaScript or Ruby might already be familiar with this type of operation, where you have an accumulator and you have the current value, which we're going to call letter. And the way that we want to sort of combine these values is to say, we'll take the phrase that we have so far, the accumulator, and we'll interpolate the new character into it. So we're just building up. So it'll start with A, and then AB, ABC, ABCD, and that'll be our phrase. So what we have there is a stream of phrases, but we have no idea how fast the user is typing. I mean, in our simulation, we know it's going to be every 500 milliseconds, but we don't sort of want unlimited requests if we're doing a type ahead where we're going to show responses of things to suggest to the user. So we want to throttle. We want to rate limit the phrases. So if we've got a stream of phrases, we can use additional APIs RxJS provides, like throttle time, and say, okay, we really only want new phrases coming through every 1 second. And then we want to make sure that whatever they're typing is encoded. So we map the current value with the encode URI component function to get something that we could maybe send up to a server. And then we have a stream of search phrases. Okay, once we have the stream of search phrases, we actually want to perform a search with them. So we have a little utility function at the bottom called search, which uses the request promise library and just goes to some API with a query string. And then that function, so search, will return a promise. So we see Rx observable from promise. So we're taking the return value of that search function and turning it into a stream from it being a promise. And it's going to be a multi-dimensional stream, because each request will have its own stream of responses, and then we flat map those onto this variable that we call the searches stream and subscribe to that. So that's a lot going on. But if we want to sort of visualize what was happening with our data, we would start with the interval. We got 0, 1, 2, 3, 4. We map it onto letters, A, B, C, D, E. Then we scan to sort of combine those letters into phrases. And then we throttle, so we do it every 1 second. So we're cutting out every other phrase. And then we map. In this case, since there's no special characters, it's not really changing anything, but we're URI encoding right now. And then finally, we flat map from a stream of requests with responses onto a flat stream of just response objects. And that's one of the real strengths of modeling things using streams, that you can very easily create these marble diagrams to visualize how data moves through your system. So now we know that we can have higher order streams, so streams of streams, that can be modeled with observables, and we've seen that we combine them both vertically and horizontally. And that's a lot to know about streams. So if we look back at our original questions, we initially just had that JavaScript function which sort of did what we wanted, but it really wasn't possible to reason deeply about what was going on. And now we know if someone asks questions like, can the stream ever signal completion? Yes, there's specifically an onComplete callback that we can register. Can an observer be unsubscribed? Yes, we have an API for that, and we know the mechanics of what will happen when we unsubscribe. What are the mechanics for when the stream will stop emitting? We know that's lazy, and you either need a subscriber or you need to publish and connect. Can the stream emit errors? Yes, there's a separate callback for registering errors differently than getting the values. Are values shared between subscribers? Well, if the stream is hot, then yes, and if the stream is cold, then no. And how can the stream interact with other streams we might create? Well, we've seen lots of examples of composing new observables and combining different observable streams with each other. So overall, observables are like a very, very powerful hammer. And like all hammers, people want to use them in areas where they don't need to be used. So where are some really good examples of areas where streams are preeminent? Well, for example, Kafka. If you think about getting events, like your database events, as a log, that log is a stream where you're constantly getting new values coming in, and you're going to want to do things with that stream of values, such as throttle it and transform it and maybe combine it with different streams from different applications. And all those operations are simplified when you have a library like RxJS or any type of observable implementation to help you reason about what's going to happen when you want to manipulate the stream of values. So another example of something that's a stream are WebSockets. So Action Cable in Rails 5, unlike request response architecture where you send a request and you get a response, with WebSockets the client can send message after message and the server can send response after response, and they don't have to be one-to-one. And so modeling what comes in and what goes back would be very well modeled with a stream. So that's another great example of an opportunity to use observables. Another example that I've seen, and I'm not an expert on Redux, so I'll leave this to other people to debate, but this simple line here is an example implementation of the Redux framework, where if you have a stream of actions, you write a reducer function to combine your actions into a single state, and then you subscribe with a render function so that whenever your state changes, you re-render your entire DOM tree. So actions in Redux are an example of using streams of values. Angular 2 also follows this pattern with writing reducers and follows the Redux pattern. Browser events in general, there's not a lot of value for turning something like a form submission into a stream because it's sort of a one-off event. But as we saw with the type ahead, if you want to do things like horizontally combined events where you want to throttle the user, maybe if you're doing something like determining if username and password are already taken on a sign-up form, there's instances where browser events actually should be modeled as a stream rather than just as a single on change callback on a text input. You want to think about what you're getting as more of a stream, and it simplifies what you're trying to model. And obviously audio video are another example of things that are streams. So I'll sort of leave it at this. Some additional resources for people that are curious, want to learn more. A lot of the information that you've seen so far is explained differently on egghead.io, where they do 5 different courses on RxJS and thinking about streams, and those are really good. There's a website called rxmarbles.com where unlike the little ASCII art marble diagrams, they've created very sophisticated diagrams where you can drag the values around and see how the output of combining different things would change. And for a cross-language reference on observables, check out reactivex.io. And then the code samples from this presentation are on my GitHub at Benedict Fischer, observable examples. So that's all I want to talk about with streams today. I hope people enjoyed it and learned something. And that's it.